this lesson, we're going to talk about the number e, lowercase e, which is approximately 2.71828, and it's irrational, so it keeps on going. This is just like some other numbers you already know about. Like you already know pi is a symbol that is about 3.14. We've talked about I this year. It's a symbol that equals square root of -1. So e is just like these. It's a symbol, it's a variable, it's a letter, but it represents a real number. The number e comes from this equation. That's 1 plus 1 over n to the nth power. And basically what happens is, as you make n larger, so if you go like 100 or 1,000 or 1,000,000, you just keep on making n larger, the number gets closer and closer to this. I'm going to show you this with the calculator. So I'll just plug in this equation. So 1 plus, and we have to put this division part also in parentheses, so it knows we want to do that separately. So 1 plus 1 over, 100, close the parentheses, all of that to the 100th power. It's 2.704. All right, we're going to do 1 plus 1 divided by 10,000, close them both to the 10,000th power, and we get 2.718, and the higher number we choose, it's just going to get closer and closer to this value. So we just need to think of e as a variable, but it has a secret identity of being approximately 2.7182 repeated. Or irrational, it just keeps on going over and over and over. So let's think about e. So we're going to see some problems like this. So 2e to the x times 5e to the 4x. For a problem like this, you just treat e like some variable. You do the 2 times the 5 to get 10. You add the exponents, so e to the 5x. Another example of this, I'll show you in a sec. Let me just erase. Another example of e is maybe e to the 3rd power divided by e to the x plus 3. So when you divide exponents, the bases are the same. They're both e. We're just going to subtract the exponents. So what that is e to the 3 minus x minus 3. We have to subtract the whole thing. You can't just subtract the 3, because you have to subtract the whole exponent. 3 minus the quantity, x plus 3, which is going to be e to the negative x. And we'll never write a final answer with a negative exponent, so you guys know to flip this over. We have 1 over e to the x. That negative sign just moves it to the bottom like this. Another thing you might have to do is say what e to a certain power is. So let's say, what's e to the 3 halves? You know that e is a number, like 2.71 or something, so you can type that in if you want. But there's actually an e button we can use. It's right here above the divide sign, so you have to hit second to get it. So you can do e to the 3 halves, and that's going to be about 4.482. There's another button with e. It's right here above the ln sign. That's e to a certain power, so that one's probably better for this. But here's just a regular e over here as well, so you have access to both of those. But they're the same. You have e to a certain power key and just an e key over here. You also might need to graph these. Actually, you will on the practice problems, and you're going to have to tell the domain and range. So here's an example from the practice. It says y equals 2e to the x minus 1 plus 1. So we're just going to press 2. Grab this e to the x down here, and that's x minus 1. Close it, plus 1. We'll graph it like this. And you can see there's an asymptote here at y equals 0, or y equals 1, sorry. And you know there's going to be one there because there's this k, this plus k outside, that's going to shift the graph up 1. So the asymptote, not the range, but the asymptote, let me write this again. The asymptote is y equals 1, and the range is y, all the values y greater than 1. the x values are anything, because it goes all the way to the left and all the way to the right. So the domain is just all the x values, which is all real numbers.